Lecture 1. Introduce the relativistic quantum mechanic theory, reinterpretation of the wave function.
Hello, I am JODY. I am an Indonesian and I am a researcher in the field of organic chemistry. I come from the background of chemistry, but I am interested to study physics because physics, especially quantum physics, is the basic of chemistry. Now, I will introduce you a new quantum mechanic theory called the relativistic quantum mechanic. What is the relativistic quantum mechanic? The relativistic quantum mechanic is a quantum mechanic based on the perspective of relativity theory. Once again, the relativistic quantum mechanic is a quantum mechanic based on the perspective of relativity theory. This is my theory. This is my idea that I have developed 8 years ago. And now I will expose it to you. How important that this theory must be proposed? Didn't we have the quantum mechanic theory that can help us to understand the quantum effect? This theory must be proposed because until now there is no right understanding about what is actually the quantum effect. The quantum effect is not the common effect of physics. The quantum effect is a relativity effect. So, the quantum effect must be explained based on the perspective of relativity. We know that the quantum mechanic theory has started from the experimental fact that electron has the character of particle and the character of wave too. The dual nature of electron makes de Broglie has proposed that electron must the formula of wavelength that is the same to the formula of wavelength of photon. Lambda is equals to h over p or equals to h over m v, where m refers to the relative mass. M equals to m sub o over root square of 1 minus v square over c square. And h is the Planck constant. H equals to 6.626 times 10 to power minus 34 joule seconds. The concept of the Broglie wavelength gives rise to the limitation to determine the position and momentum of electron. That limitation is set by Heisenberg as the uncertainty principle. Delta x times delta p more than or equals to h over 4p. This is the uncertainty principle. The uncertainty principle. Based on the uncertainty principle, Schrödinger has developed a mathematical model to describe the position and momentum of erector. This mathematical model we know as the Schrödinger equation. The Schrödinger equation is started from the wave equation. Y equals to A cos omega times T minus X over V minus IA sine omega times T minus X over V. Where omega refers to the angular frequency. Omega equals to 2pf. And I is the imaginary quantity. I equals to the root square of minus 1. Because cos theta minus I sin theta equals to E to I theta. So the wave function psi could be written as psi equals to A times E 2 minus 2 pi times ft minus fx over phi. Well, because f frequency equals to E over H and f over phi equals to 1 over lambda or equals to P over H, the wave function psi become psi equals to A times E 2 minus 2 pi over H times Et minus Px. The constant H over 2p is commonly written as H bar. So the wave function psi could be written as psi is equals to A times E 2 minus I over H bar times ET minus Px. Okay, psi is equals to A times E2 minus I over H bar times ET minus Px. This is the wave function of a particle that moves free along past x direction. This wave function is just right for the particle that moves free, while what we needed is a wave function of particle that is limited by a certain situation. What we have to do is to find out a principal different equation of psi and then solve psi for the special case. That principal different equation of psi we know as the Schrödinger equation. So to find out the Schrödinger equation, we must differentiate psi to x twice and psi to E once. I'll write again the formula of psi. So psi equals to A times E2 minus I over H bar times ET minus Px. If we differentiate psi to x twice, we get d square psi over dx square equals to minus p square over h bar square times a times e 2 minus I over h bar times et minus dx. So if we have an exponential function y equals to a to kx dy over dx equals to k times e to kx. If we differentiate y to x once again, we get d square y over dx square equals to k square times e to kx. That's why we find this result. Thus, d square psi over dx square equals to minus p square over h bar square times psi. And if we differentiate psi to e once, we get d psi over dt equals to minus I over h bar times E times psi. By ignore the relativistic consideration, the total energy E of a particle is the combination of kinetic energy K equals to half of mv squared and potential energy V. So E, total energy, is equals to mv squared over 2 plus V, or equals to P squared over 2m plus V. If we multiply the both sides of total energy equation by psi, we get E psi equals to P squared over 2m psi plus V psi. Okay, based on this result, we get h bar minus h bar over I d psi over dt equals to minus h bar square over 2m d square psi over d x squared plus v psi. If we multiply the left side of this equation by I over I, we get I h bar d psi over dt equals to minus h bar square over 2m d square psi over dx squared plus v psi. This is the Schrödinger equation depend on time in one dimension. I don't mean to discuss Schrödinger equation in detail in this lecture because, as I have talked before, that the quantum effect is the relativity effect. It makes a consequence that we have to formulate the wave function of particle in different perspective of quantum mechanics. For this goal, let us reinterpret a wave function set by a complex function psi equals to psi sub 1 minus I psi sub 2. For example, in our case, psi equals to A cos theta minus IA sin theta. This wave function consists of two parts. Those are the real part psi sub 1 and the imaginary part I psi sub 2, where psi sub 1 equals to A cos theta and I psi sub 2 equals to IA sin theta. The real part psi sub 1 describe the motion of particle in the real space, and the imaginary part I psi sub 2 describe the motion of particle in the imaginary space. Once again, the real part psi sub 1 describe the motion of particle in the real space, and the imaginary part I psi sub 2 describe the motion of particle in the imaginary space. The real space and the imaginary space are the two spaces of the overall existence of particle as a particle and as a wave too. We can define the real space as the space of the existence of particle as a particle, and the imaginary space is the space of the existence of particle as a wave. If we are present in the real space, we will find that the existence of particle as a particle is real, and the existence of particle as a wave is imaginary. But if we are present in the imaginary space, we will find that the existence of particle as a particle is imaginary, and the existence of particle as a wave is real. So if we are present in the imaginary space, we will find that the wave function psi is in the Schrödinger equation will not to be applied to describe the motion of particle in that space. In this situation, we have to formulate other wave function applicable in the imaginary space. Such wave function should express that the quantity sin theta is real and cos theta is imaginary. In addition, there is the difference in symmetry between the real space and the imaginary space. The real space is the space that is anti-symmetric, but the imaginary space is the symmetry space. So, the wave function applicable in the imaginary space should be written as psi sub omega equals to A sin theta plus IA cos theta, or psi omega equals to I times A cos theta minus I A sine theta, or equals to I psi. Thus, we find that the wave function applicable in the imaginary space psi sub omega is the imaginary form of psi. That is the wave function applicable in the real space. In the perspective of relativity, the wave function psi and psi omega should be viewed as the complementary wave function of a wave function applicable in the space-time system. Once again, in the perspective of relativity, the wave function psi and psi omega should be viewed as the complementary wave function of a wave function applicable in the space-time system. It will be clear if we view the space-time system as the combination of the two coordinate systems. Those are the spatial coordinate system and the time coordinate system. The spatial coordinate system refers to the real space, that is the space where the existence of particle as a particle. And the time coordinate system refers to the imaginary space, that is the space where the existence of particle as a wave. Thus, psi is the wave function applicable in the spatial coordinate system. And we can write psi equals to psi s. S refers to spatial. On the other hand, psi omega is the wave function applicable in the time coordinate system. And we can write psi omega equals to psi t. Therefore, if psi st is the wave function applicable in the space-time system, so we have to conclude that psi st is the combination of psi s and psi t. There are two ways of combination of psi s and psi t. First, psi st equals to psi s minus psi t, and second, psi st equals to psi s plus psi 2. There are two ways of combination of psi s and psi t to form psi st. These two ways of combination of psi s and psi t to form psi st state that the overall space-time system consists of two parts. Those are the real space-time system, that is the spatial coordinate system, and the imaginary space-time system, that is the time coordinate system. It means that the spatial coordinate system is actually a 4-dimensional system, consists of 3 length axes and 1 time axis. But in the spatial coordinate system, the time axis is imaginary. On the other hand, the time coordinate system is actually a 4-dimensional system, consists of 3 time axes and 1 length axis. But in the time coordinate system, the length axis is imaginary. That's why we define psi s, or psi equals to a cos theta minus ia sin theta, and psi omega or psi t equals to a sin theta plus ia cos theta. There are 2 classes of particles we have now. Those are fermion and boson. Fermion is the class of particle has the character of particle, and boson is the class of particle has the character of wave. Because the real space-time system has the antisymmetric behavior, and it load the existence of particle as particle, so the combination psi st equal to psi s minus psi t, or equals to psi minus I psi, is the combination of psi s and psi t applicable in the real space-time system, load the existence of fermion. The combination of psi s and psi t applicable in the real space-time system log the existence of fermion. On the other hand, because the injury space-time system has the symmetric behavior and it load the existence of particle as a wave, so the combination psi st equals to psi s plus psi t, or equals to psi plus I psi, is the combination applicable in the imaginary space-time system load the existence of boson. The combination of psi s and psi t applicable in the imaginary space-time system logs the existence of boson. I write again the two ways of combination of psi s and psi t. First, psi st equals to psi s minus psi t, or equals to psi minus I psi. And second, psi st equals to psi s plus psi t, or equals to psi plus I psi. This is the combination of psi s and psi t applicable in the real space-time system, or the existence of fermion, and this is a combination of psi s and psi t applicable in the imaginary space-time system, or the existence of boson. We find that psi st is a complex function, consists of the real part psi and the imaginary part psi omega equals to I psi. In this situation, we should write psi and psi omega are the conjugated wave function. The term conjugated wave functions comes from the mathematical operation to normalize psi st. Normalization of psi st fulfill the magnitude of psi st star psi st equals to psi minus I psi times psi plus I psi. This is the normalization of psi st applicable in the real space-time system, or the magnitude of psi st star times psi st equals to psi plus I psi times psi minus I psi. This is the normalization of psi st applicable in the imaginary space-time system. Thus we find the magnitude of psi st star times psi st is equals to 2 psi squared, or equals to 2s squared times cos theta minus I sin theta times cos theta plus I sin theta, or equals to 2s squared times cos square theta plus sin square theta, or equals to 2a squared, because cos square theta plus sin square theta is equals to 1. Okay. Now, if we state psi f as the wave function applicable in the real space-time system about the existence of fermion, so psi f equals to psi s minus psi t, or equals to psi minus I psi, and psi b are the wave function applicable in the imaginary space-time system from the existence of boson. So psi b equals to psi s plus psi t, or equals to psi plus I psi. We find that psi f and psi b are the complex conjugate one another, because the complex conjugate of psi minus I psi is psi plus I psi, and the complex conjugate of psi plus I psi is psi minus I psi. Because the magnitude of psi st star times psi st is that 100% of probability to find particle in the space-time system, we have to conclude that the real space-time system and the imaginary space-time system are conjugated each other to realize 100% of probability to find particle in the space-time system. In this situation, we will find that the amplitude of psi must fulfill 2a squared is equals to 1, and a equals to 1 over root square of 2. Now, if we have two identical particles, that is to say particle 1 and particle 2, where in the space-time system these two particles are separated by the spatial coordinate system and time coordinate system, you can say that in the space-time system these two particles stay on the two different quantum states. That is to say, A and B quantum state represented by psi A and psi B. If in the spatial coordinate system particle 1 stay in A quantum state and particle 2 stay in B quantum state, so the wave function applicable in the spatial coordinate system fulfill psi s equals to 1 over root square of 2 times psi 1 times psi b 2. To realize 100% of probability to find particle in the space-time system, so in the time coordinate system, particle 1 will stay in B quantum state and particle 2 will stay in A quantum state. So the wave function applicable in the time coordinate system fulfill psi t equals to 1 over root square of 2 times psi A 2 times psi b 1. So the wave function applicable in the real space-time system, lot the existence of boson must fulfill psi f equals to 1 over square of 2 times psi A1 and psi B2 minus 1 over square of 2 times psi A2 times psi B1. On the other hand, the wave function applicable in the imaginary space-time system without the existence of boson fulfill psi b equals to 1 over square of 2 times psi a1 and psi b2 plus 1 over square of 2 times psi A2 times psi B1, where psi F and psi B are the conjugate complex one another, which means that the real space-time system and the imaginary space-time system are conjugated each other to realize 100% of probability to find particle in the space-time system. We know that the probability distribution of a fermion fulfill Fermi-Dirac distribution function, and the probability distribution of a boson fulfill Bose-Einstein distribution function. In the boson system, the presence of a particle in a quantum state adds the probability of other particle to occupy that quantum state. But in the fermion system, the presence of a particle in a quantum state prevents other particle to occupy that quantum state. So fermion is the class of particle obey Pauli's exclusion, but boson is the class of particle doesn't obey Pauli's exclusion. The wave function psi used in the Schrödinger equation is applicable for fermion system. But if all electron in the atomic shell is fermion, how possible we can see the matter? And how possible we can find the electric current? Because there is just one quantum state for each electron. In this situation, we will just find the matter in a very, very tiny size that called compound. Of course, it is not in accordance with the physical reality we see. Due to the space-time system, there are two classes of electrons occupy the atomic shell. These two classes of electrons are fermion electrons and boson electrons. Fermion electron is the class of electron obey Pauli's exclusion, but boson electron is the class of electron doesn't obey Pauli's exclusion. The quantum behavior of boson electrons make possible for us to find the matter in the big size we can see, and it makes possible for us to find the electric current. Why? Because boson electrons will spread out to occupy very much quantum state in the matter system. As I have shown that the wave function psi and psi omega is the complementary wave function of the wave function applicable in the space-time system. The combination of psi and psi omega realize 100% of probability to find particle in the space-time system. So if we just use psi to describe the existence of particle, we lost other part of particle needed to realize 100% of probability to find particle in the space-time system. At this point, I have to say that the quantum mechanic theory based on the Schrödinger equation has limitation to describe the overall existence of particle in the space-time system. Therefore, we need a new quantum mechanic theory, that is the relativistic quantum mechanic, to describe the overall existence of particle in the space-time system. Well, before I finish this part, I want to emphasize once again that the quantum effect is not the common effect of physics. It is the relativity effect. So the quantum effect must be explained based on the relativity paradigm. In the next video, I will discuss about the Einstein clock, that is the clock can definite time and length quantities at once. But the common clock is the clock just can definite time quantity. I will explain what is actually the space-time system.